So good evening all, welcome to SAKALAVIDYA YouTube channel. Okay, today morning due to technical issues I was not able to give the second session live streaming. So now may be possible, may not be possible, because I am just doing just experiment now. So demo classes, demo now, just now. Are you able to hear my voice? Just, are you able to hear my voice? Are you getting my voice? Lavanya Ramaya, after a long time. Ajay Khanna, tell me, are you able to get my voice or not? Okay? Jayant. Okay, thank you. Am I audible to you? Am I visible to you? Okay, thank you. Okay, we shall continue. Right. Binomial theorem. Part 3. Okay, part 3. Right, thank you everybody. Third question completed, I think so. Yes, fourth question. We need to discuss fourth question. Okay, it might be. Okay. Right. The number of terms in 1 plus 5 root x whole to the power of 9 plus 1 minus 5 root 2 x whole to the power of 9 in brackets x greater than 0 is first option 3, second option 5, third option 4, fourth option 6. Right. Some disturbance coming. Okay. You can hear. Voice is less. Okay. So technical problem is there. Today we will check. So tomorrow we will rectify it. Okay, now solution. The number of terms in 1 plus 5 root 2 times x whole to the power of 9 plus 1 minus 5 root 2x whole to the power of 9. So we have the formula. The number of terms in x plus a whole to the power of n plus x minus a whole to the power of n equals to n plus 1 by 2. If n is odd, see here n equals to 9, which is odd. Therefore, number of distinct terms or number of terms is equal to 9 plus 1 upon by 2 equals to 10 by 2. That means 5 terms. So desired answer is second option. Second option is the right option. Okay. Now I will check my voice now once again. Wait. 1 minute. Right, if n is even, already I discussed in the last session, if n is even, n by 2 plus 1, n by 2 plus 1, right. Now the fifth question, right, the number of terms in 1 plus 3x plus 3x square plus x cube raised to 6 is okay. I already told you I increased it. Actually some problem is there with the sound etc. in the morning only, so that can be rectified later. Otherwise use headphones, right. First option is 17, second option 19, third option 21, fourth option 16. Okay, right, the number of terms in 1 plus 3x plus 3x square plus x cube plus all to the power of 6 is, here see, first we need to find out this 1 plus 3x plus 3x square plus x cube is equal to 1 plus x whole cube. 1 plus x whole cube expansion is this one now, so that we can write 1 plus 3x plus 3x square plus x cube whole to the power of 6 can be written 1 plus x whole cube and raise it to 6. This becomes 1 plus x whole to the power of 18. So therefore here n is equal to 18. Number of terms is equal to n plus 1, because it's the only binomial. So n plus 1 equals to 18 plus 1 equals to 19. Understood now? So that means second option is the right option. Right option. Okay. So 1 minute wait now. We'll check. Hello, shall I continue? Are you able to hear my voice? Are you able to hear my voice? Voice is not audible. Okay, all of you use headphones. Best. Okay. Right. Right. Next, sixth question. The number of distinct terms. Number of distinct Okay. The number of distinct terms in A plus B plus C plus D whole to the power of n. N belongs to n is first option n plus 3 C 2, second option n plus 3 C3, third option n plus 2 C3, fourth option n plus 4 C3. So this is the problem. Okay, I checked it two or three times. Next solution. The number of distinct terms in x1 plus x2 plus x3 plus so on dash xr whole to the power of n equals to n plus r minus 1 c r minus 1. This is the formula shortcut we have. Understood now? That means here in this problem n means n only. Here r means how many are there? 1, 2, 3, 4. R is equal to 4. Therefore, required number of terms equals to n plus 4 minus 1 C4 minus 1, that is n plus 3 C3. That means second option is the right option. Okay. Seventh one. seventh question. Seventh question. The number of distinct terms in a plus b plus c plus d plus e whole to the power of 3 is first option 35, second option 38, third option 42, fourth option 45. Okay. So now the number of terms in x1 plus x2 plus x3 plus so on xr all to the power of n equal to n plus r minus 1 cr minus 1. Here n equals to 3, r equals to 1, 2, 3, 4, 5, r equal to 5. Therefore, required number of terms in the given expansion is equal to n means 3 plus 5 minus 1 c 5 minus 1. This is 7c3. 7c3 we need to find out. 7c3 means 7 into 6 into 5 upon 3 into 2 into 1. 3 2 just 6, 6 gets cancelled. 7 into 5 is 35. So 35 is the number of terms. So first option is the right option. Okay. No, the morning actually technical problem arises in my computers, both the computers. Now I am using another computer, but in another computer also I am getting. So we need to change the computer. That's the problem for us. Right. Eighth question. The coefficient of eighth term in the expansion of in the expansion of 1 plus x whole to the power of 10 is. So 1 minute, I will check now. Wait now. Hello? It's okay? Sound is okay now? Sound is okay. Am I audible to you? Am I audible to you? Suma? Swati? Am I audible? Hello? 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 Audible? Okay. Thank you. Thank you. Thank you. Okay. Hello? Hello? Okay now? Right. First option is 120. Second option is 7. Third option is 10ch. Fourth option is 210. Fourth option is 210. Okay. Okay. Thank you. Thank you. So the coefficient of eighth term in the expansion of 1 plus x whole to the power of 10 is 120, 7, 10ch and 210. See, now this question can be done like this. Solution. The coefficient of TR plus 1 general term in 1 plus x whole to the power of 10 is equal to NCR. This is the formula. Here N stands for 10, eighth term T8 means this we can write T7 plus 1. That implies R value is equal to 7. Therefore, coefficient of eighth term equal to NCR. N is 10, C 7. So we have one formula. NCR equals to NCN minus R. So now this equals to 10C, 10 minus 7 is 3, 10C3. 10C3 equals to 10 into 9 into 8 upon 3 into 2 into 1. 3 2 4 ja, 3 3 ja. 12 into 10, 120. That means first option is the right option. First option is the right option. Ninth one. ninth one. Okay, let us move to the ninth question now. If A and B are the respective coefficients of x to the power of m and x to the power of n in the expansion 1 plus x all to the power of m plus n, then okay, then first option a plus b equals to m plus n, second option a equals to 2b, third a equals to b, fourth option b equals to 2a. This is the question. Right, if a and b are the respective coefficients of x to the power of m and x to the power of n in the expansion 1 plus x all to the power of m plus n, then we need to establish relation among a, b and m and n, or sometimes in between relation between a and b also. So that we need to check here. There's the hint. This is standard form 1 plus x all to the power of n form. See, the coefficient of x to the power of r in 1 plus x all to the power of n equals to NCR. That is nothing but coefficient of TR plus 1. So now what is A here? A is the x to the power of m coefficient. Therefore, see, A equals to x to the power of m coefficient in 1 plus x all to the power of m plus n. So this equals to m plus n c m. Say equation 1. B equals to x to the power of n. This x to the power of n coefficient. X to the power of n coefficient in same expansion 1 plus x all to the power of m plus n, whose value equal to m plus n c n. This is 2. If you check very carefully, as NCR equal to NCN minus R, this m plus NCM equals to m plus NC, m plus n minus m, m cancel n. That means here 1 equals to 2. Therefore, A equals to B. That means third option. 10th question. 10th one. 10th question. Right. If the coefficients NC4, NC5 NC6 of 1 plus x whole to the power of n okay. If the coefficients NC4, NC5, NC6 of 1 plus x whole to the power of n are in AP, then if the coefficients NC4, NC5, NC6 of 1 plus x whole to the power of n are in AP, then n is equal to repeating, how is repeating? First option 12, second option 11, third option 7, fourth option is 8. Okay. So now solution NC4, NC5, NC6 are in arithmetic progression. So we have one condition. Suppose A, B, C are in arithmetic progression. We have 2b equals to a plus c. This condition we have. 2b is equal to, okay, right. So this can be written 2 times NC5 equal to, we can write NC4 plus NC6. Am I correct now? Divide both sides by NC5. So NC5 equals to NC4 plus NC6. Divide by NC5. 2 equals to NC4 upon NC5 plus NC6 upon NC5. Here we have one shortcut. NC6 upon NC5 equal to n minus 5 upon 6, NC5 upon NC4 equal to n minus 4 by 5. With the help of these basic facts, so this can be written NC4 by NC5 is 5 upon n minus 4 plus NC6 by NC5 is n minus 5 upon 6. Here LCM. What is the LCM? 6 multiplied by n minus 4, 30 plus n minus 4 into n minus 5. N square minus 9n plus 20. So now cross multiply. We get n square minus 9n plus 50 equals to 12n minus, this will be 48. Here we can write n square minus 21n plus 98 equals to 0. It's a quadratic equation in n. Understood now? Okay. This sound is enough. Okay, thank you, thank you. So now here 98 can be written minus 14 times minus 7. That's why this can be written n minus 14 into n minus 7 equal to 0. So we get n is equal to 7 or 14. So this is the answer. N is equal to 7 or 14. That means in the option we have 7. So that means third option is the right option. Okay, now okay, so we shall continue in the next session because the sound is not comfortable us. Thank you, bye bye, see you. Okay.